I1A Physics 3 SP015. Number 1, a 1.5 kg ball was kicked with initial velocity of 40 meter per second at the angle of 30 degree with the horizontal line. Calculate the initial momentum of the ball and also the horizontal and vertical components of the initial momentum. So now you have M, mass is 1.5 kilogram, and then you have initial velocity is 40 meter per second, and the angle will be 30 degree. So now calculate initial momentum. Initial momentum will be mu. So PI is equal to M 1.5 times dengan 40, where you will get 60 kilogram meter per second. Okay, and then next what you want is a horizontal and vertical component. So for horizontal component will be px, which is mu x, mu cos theta. So what do you get? M is 1.5, u is 40, cos 30 degree, which will be 51.96 kilogram meter per second. Okay. And then calculate for the vertical. So for vertical component, vertical component is py, which will be muy, and then mu sin theta, where 1.5 times dengan 40 sin 30. So what do you get here for y component, which 30 kilogram meter per second. Okay, and then for number 1b, sorry, for 1b, what do you have here is two cars A and B are moving in opposite direction at 90 km per hour and 70 km per hour. The cars collide with each other and bounce off as shown in figure. The mass of car A, MA, 1500 kg, and the mass of car B is MB, 2000 kg. Final velocity for A is 15 km per hour with angle 35 degree. Calculate the final velocity of car B, VB, and its direction. So now what do you have here is mass. Okay, you have mass A 1500 kilogram, and then mass B, which will be 2000 kilogram, and then you have UA in the diagram 90 kilometer per hour. So here you can convert it. So just convert it here. So what do you get here is 90 times 10 power of 3 over 60 times 60, where you get 25 meter per second. And then for UB will be 70 kilometer per hour, and you will get 70 times 10 power of 3 over 60 times 60, and 19.44 meter per second. For VA, what do you have here is 15 kilometer per 1 hour. So 15 times 10 power of 3 over 60 times 60, and then you will get 4.17 meter per second. Okay, so for x-axis, what do you have here is okay, Okay, I write down here summation x axis, summation p I initial for x, and also summation p final x. Okay, so you have ma ua x plus mb ub x equal to ma va x plus mb vb x. Okay, and then substitute value. So we substitute value here, 1500 times dengan ua x, just directly, so directly just put down 25 plus mb is 2000, and then it is opposite direction, which is negative 19.44, and then equal to 1500 vax. You have to resolve it. Here you have vax, which will be equal to va cos theta. So negative 4.17 because it's left to the left, cos cos 35. Okay, plus 2000 times vbx. Okay, and then you calculate it, and you will get your vbx will be equal to 1.87 meter per second. Okay, next for y axis, it will be summation p initial y equal to summation p final y. So for y component, it will be ma uay plus mb uby equal to ma vay plus mb vby. Okay, for initial it will be 0, and then for final ma vay will be 4.17 because it is upward, sine 35 degree, and then plus 2000 times dengan vby. Okay, so what do you have here? You will get your vby is negative 1.79 meter per second. Okay, so for your velocity of car B, it will be VB will be equal to square root VB x squared plus VB y squared. And then you substitute your value, 1.87 squared plus negative 1.79 squared. Okay, don't forget your square root. So we get your VB is 2.59 meter per second. So this is your speed. And then how about your direction? So direction will be tangent theta is equal to VB y over VB x. Okay, so theta will be equal to tangent inverse VB y over VB x. Okay, here theta will be equal to tangent inverse VBY is negative 1.79 over 1.87. And what do you get here? Theta is negative 43.75 degree. So now you get your direction here, and your magnitude is 2.59 meter per second. Next is number 2. Number 2 is state that a 3 kilogram cube is placed on a rough plane. The plane is then slowly tilted until the cube starts to move from rest. This occurred when the angle of inclination is 25 degree. So calculate the static frictional force between the cube and the rough plane. So now what do you have here is your mass is, okay, you write down the information given, 3 kilogram. Your u will be equal to 0 meter per second. Initial velocity, your theta actually is 25 degree. And then here we have here your static frictional force, meaning that you can use summation F is equal to ma, which will equal to 0. So we have to know all the forces acting on the cube. You have a normal force here, and then weight, then because it's downward, so you have a frictional force there, static friction force, and it has v there, so meaning that your acceleration will be 0. And then here you have what do you have? You can say that in x component it will be summation fx equal to 0. Okay, so summation fx is equal to 0. In x component you have the other one is wx, and also so you have wx and also static frictional force. Then wx is mg sine 25 degree minus fs will be equal to 0. How do you get that? Because your angle will be here, angle is 25 degree, so wx will be opposite. When it is opposite, it will be sine 25 degree. And then you substitute value, so fs will be equal to 3 times 9.81 times sine 25 degree. Okay. So fs will have 12.44 Newton. Okay, next, a 2 kilogram object is placed on a rough plane inclined at 30 degree with the horizontal as shown in figure. It is released from rest and accelerates at 4 meter per second squared. Calculate the frictional force acting on the object. Okay, so now what do you have here? Is given here is the mass, which is 2 kilogram, and then your theta will be 30 degree, where you have the acceleration is 4.0 meter per second squared. Okay, what do you have here? You must draw either a free body diagram or forces acting on the object. So now I try to draw a free body diagram where actually we have a normal force there, and then your frictional force Fk, because the object is accelerating downward. And then here we have the weight. Okay, so here the angle is 30 degree. Okay, so because we want the frictional force is in x component, and then we can resolve for w, where it actually has wx there. Okay, so your actually wx will be mg sine theta. Okay, so for summation fx will be ma, because it accelerate in x component. So there you have two forces, mg sine theta minus fk is equal to ma. So fk will be mg sine theta minus ma. Okay, substitute all the value given. 2 times 9.81 times sine 30 degree minus 2 times acceleration is 4, and then you calculate and you will get 1.81 Newton for your kinetic frictional force. Actually it has no, okay, Newton, sorry Newton. Okay, then next is number 4. So for number 4, you have a 30 kilogram block is placed on an inclined plane with an angle of 20 degree. As shown in figure, the coefficient of kinetic force between the block and the inclined plane is 0.2. So now draw a free body diagram, and also you have to determine the kinetic force Fk. All you have to do is draw a free body diagram. Now just write down all the information given. So mass is 30 kilogram and the angle is 20 degree, and you have your mu. Mu is a coefficient of kinetic frictional force is 0.2. Okay, for part A, draw all the free body diagram where you have a normal force there, and then for weight, and because it accelerating downwards, so the frictional force is acting upward, kinetic frictional force. Okay, so now this is your free body diagram, and then next you want to find your kinetic frictional force, where you can find you have to find from y component. Summation fy will be equal to 0. So here you have a normal force and also a weight in x component, where it will be, okay, if we can resolve here, it will be, here will be mg sine this will be mg cos theta, because your angle here, and then mg here sine theta. Okay, so this is for wy, and then this is for wx. Okay, so summation fy n minus wy will be equal to 0, where n will be equal to mg cos theta. So you can calculate your n actually, n will be equal to 30 times 9.81 times cos 20 degree. Okay, and then for your, you want to find your kinetic frictional force. So kinetic frictional force is actually equal to mu k n. Okay, and then it will be 0.2 times 30 times 9.81 cos 20 degree. So what do you get there? You will get 55.31 Newton. And then for number 5, so for number 5 here, you have two blocks there, A and B. A is 4 kilogram on a rough 30-degree inclined plane hanging 1 kilogram. Block B by a massless cable passing over the frictionless pulley as shown in figure. When the objects are released from rest, object A slides down the inclined plane with a friction force of 6 Newton. Calculate the acceleration of the object and the tension in the cable. So what you have to do is to draw a free body diagram first. Before free body diagram, write down all information given. MA will be 4 kilogram, and then theta is 30 degree. MB will be 1 kilogram, and your friction force will be 6 Newton. Okay, so draw a free body diagram for block B. Block A first. What do you have here is normal force, and then weight, and because it's accelerating downwards, so your frictional force is upward, and you have your tension there. Okay, so this is your free body diagram for block A. So from block A, we can get one equation. So summation fx is equal to m a, and you have t plus wx minus f equal to ma. So t plus mg sine theta minus f equal to ma. So ma here, and substitute all the value. T plus 4g times sine 30 minus 6 equal to 4a, and just simplify. T plus 2g minus 6 equal to 4a. Okay, so this was the first equation, and then you can do the second equation for block B. So for block B, your free body diagram is tension upward and WB is a downward. So summation Fy is equal to MBE. So MBG minus T is equal to MBA, because acceleration is downward. Okay, now what do you get here? Substitute value. 1g minus t equal to 1a, so t equal to g minus a. So this will be second equation. Okay, and then you just substitute equation 2 into equation 1. So it will be g minus a plus 2g minus 6 equal to 4a. So now you will get 5a equal to 3g minus 6, and your a acceleration 3 times 9.81 minus 6 over 5, and you get your acceleration is 4.69 meter per second squared. How about your tension? So B, just substitute your value for A. You can use T equal to G minus A. So 9.81 minus 4.69, and you get your tension, which is equal to 5.12 Newton. Number 6. Blocks A and B of masses 3.5 kg and 2.0 kg are connected with a light string across a smooth pulley. At t0 second, block A is pulled by a 30 Newton force F. The coefficient of kinetic friction between block A and table is 0.20. So A calculate acceleration of both blocks, and B time taken by block B to move upwards by 1 meter. Write down the information given. Mass of A is 3.5 kg. Mass of block B is 2.0 kg. And T is equal to 0 second. Then block A is pulled by 30 Newton. And the coefficient of kinetic friction is 0.2. So for part A, we draw a free body diagram where here you have normal force and then of course weight. For block A, tension, and then force F, where it has a angle here 30 degree, and it accelerating to the left, meaning that the kinetic frictional force is to the right, Fk. Okay, now we focus on block A, where for block A, for y component, summation Fy will be equal to 0. Okay, and then we have n plus Fy minus Wa equal to 0. So here n will be equal to mag for W weight of A minus F sine theta. Okay, and then you can find the kinetic frictional force, which equal to Fk equal to mu kn. Okay, substitute the value. Mu kn is actually mag minus F sine theta, where it will be 0.20. Mass of A is 3.5 times dengan 9.81 minus F is 30 sine 30 degree. Okay, and we can get here 3.87 Newton. Okay, this is for block A. For block B, for block A, still block A, sorry. For block A, for x component will be equal to it has acceleration, so ma. Okay, so for this part we have fx is positive because it is same direction as acceleration, minus t minus Fk equal to MAA. So here F cos theta minus T minus Fk equal to MAA. Okay, substitute value 30 cos 30 degree minus so for Fk is 3.87 just now, minus T equal to 3.5A, and then simplify 22.11 minus T equal to 3.5A. Okay, so this will be our first equation, and then for the second equation is from the block B. Okay, block B, draw a free body diagram. We have a tension, and then also we have a weight for block B. Okay, just two, and it accelerating upward. So summation only in y component equal to MPA, and it will be T minus WB equal to MBA. Okay, so it T minus MBG minus equal to MBA. Substitute value T minus 2 times 9.81 equal to 2A. Okay, so it will be T minus 19.62 equal to 2A. So this will be second equation, and just solve for both equation. You can use your calculator or manually. So if we do manually, it will be equation 1 plus equation 2, and you will get 2.49 equal to 5.5A. Okay, so A will be 0.45 meter per second square. Okay, this is for B. S is 1 meter displacement, so use S equal to UT plus half AT square. Actually your U is equal to 0, so 1 equal to 0 plus half A is 0.45 times T square, and then you can get your T will be equal to 2.11 second.